Okay. So I didn't write the time. I always do that. Okay, so so basically we've got the glomerulus, right, which has an afferent arteriole has blood coming from the body to the kidneys, right? It goes in and it kind of like squiggles around like that, and then this is the efferent. So we got efferent and afferent. Okay. Oops. And then so surrounding this is like the capsule, right? Yeah. Yeah, so this is the capsule that's surrounding it, and then it kind of filters off. And this is the proximal convoluted tubule, right? It's leaving the capsule, right? Grab my own markers. These things aren't very good. Okay. All right, so what causes filtration is basically a difference in pressures, right? So so around the glomerulus, you'll have these cells called podocytes, right? And these capillaries have fenestra, or they like have holes basically in them for the filtrate to pass through, right? And so it's got like this network of like really tight spaces kind of surrounding these capillaries to prevent like everything from going in, right? Just kind of the smaller molecules and more of just basically the fluid or the plasma portion, right? And so, and this is driven by pressure basically, right? So the pressure pushing outward is called the hydrostatic pressure, and this pressure comes from basically your systemic blood pressure, like the pressure coming in this way, and the rest of your body causes some hydrostatic pressure, right? All right. But you also have some pressures working against it, right? So first we've got our capsular pressure, which is basically like the fluid filling up in the capsule generates pressure, so that pushes this way against, right? And then we have also some osmotic pressure. So basically, osmosis is the travel of water through a selectively permeable membrane, right? So water always wants to travel towards whatever is more concentrated, right? And so the blood obviously is going to have tons of particles in it, red blood cells and stuff, so it's going to be a lot more concentrated than this space right here. So the water is going to want to flow actually into the blood, right? And so, and I believe, okay, yeah, so that drive of water wanting to go this way creates pressure in the opposite direction. So what needs to happen is this hydrostatic pressure needs to be greater than these two combined for filtration to happen. Does that make sense? Because if these ones were greater than the hydrostatic pressure, then there wouldn't be enough driving force to push the fluid out. It would just stay in, right? And so, and I think they give you some numbers in the book, like this is usually like 50 millimeters of mercury. Osmotic pressure is like 30. And the capsular pressure is like 10, usually. So combined, we have a net pressure this way of 10. And this would be called your filtration pressure. Okay. And this is kind of the magic number, because first of all, this number needs to be it needs to be a positive number, right? In order for filtration to even occur.
Yeah.
But you don't want it to be too high, because then you're pushing everything out, too much stuff, yeah, and maybe you could injure these capillaries and stuff. So you don't want this to be too high, right? And so this is kind of, this 50 is what the pressure always wants to be, because I'm pretty sure these are always around these numbers. And so the 50 needs to remain constant so that we keep this at 10, right?
So what if that 50 became higher? What regulates that?
That's a great question. Okay, so we need to have a constant pressure in here, right? But in our body, our blood pressure is constantly going up and down, right? And so your body has a way of adjusting to make sure this kind of always remains the same, right? Okay, so for example, let's say if we had an increased blood pressure in the body, so that means there'd be more pressure coming in this way, right? So what would happen is that at the afferent arteriole, you'd have constriction, right? So you're letting less blood in to the glomerulus, right? Because you don't want all this pressure to get in here, right? Another thing it'll do is it'll cause dilation of the efferent, right? It'll make it easier for blood to leave, basically, so that you can lower this pressure, right? And, or, you know, if it's the opposite, right? Let's say your blood pressure drops, and so this pressure would drop too, right? And so what would happen is it would cause dilation of the afferent, right? And then constriction of the efferent to bring up the pressure within the glomerulus, right?
Are there like receptors in there?
Mm-hmm. Yeah, so right around your afferent arteriole, there's the juxtaglomerular apparatus, right? Thanks. And it basically is measuring flow of blood into the capillaries, right? And so if that flow becomes too fast, it'll kind of send a signal to the brain and stuff and cause the smooth muscle around these arterioles to contract, to constrict it, basically. Or it'll cause it to dilate, to release, depending on what needs to happen. Does that make sense? Like, for example, if you wanted to build up this pressure, you'd close off where it's leaving and open up where it's coming in, right? Mm-hmm. And it's not like it completely constricts it, you know, or anything, but it's kind of like, this is how it kind of fine tunes it. Like, it opens up, right? And then to fine tune it, it kind of constricts here a little bit to bring this pressure up to where it needs to be. And so this is kind of a instantaneous regulator, right? But there's also hormonal regulators, right? Like your body can release the like ADH or the renin-aldosterone type system to bring this blood pressure up or down, right? So that you don't have to make as big as an adjustment right here. Does that make sense? So your body can lower the total blood pressure to kind of help lower this down as well, or raise it up.
ADH is the antidiuretic. Okay, remind me what that does. I know diuretics make you pee.
Yeah, so antidiuretic would make you what?
Not pee.
Not pee, right, exactly.
Okay. How does that?
Yeah, no, so that's a good question. So, so you good on this though?
Yeah.
Does it make sense? Okay.